Hi everyone! Today we're going to be learning about scale models. So I'm sure you all are familiar with some type of scale model or drawing. They appear in a lot of places on maps, or a lot of times they are in a drawing book when you want to copy an image. There are scale models such as Lego representations. A bunch of different places. You have probably run into a scale model in your life at some point or another. A scale model is an object or a drawing with lengths that are proportional to the object that it represents. So let's say that on a map, it a lot of times will give you the scale. So for this example, it says the scale on the map is 0.4 inches for every 40 miles. Using a ruler, you found that the distance from Nashville to Memphis is about 1.5 inches. Find the actual distance from Nashville to Memphis. So what we're going to do is that we know that this map is proportional to real life. So I know that every 0.4 inches on the map is the same as 40 miles. So I'm going to set that up as a proportion. Now I know that I measured 1.5 inches on the map. I know that that needs to go in the numerator because the map in inches is in the numerator. Everything in the denominator is my real world measurement. And it's measured in miles. So whatever my answer is, the units are going to be in miles. Now, you should be really familiar with solving this by now. We'll cross multiply and divide 40 times 1.5. That gives me 60, and then divide 60 divided by 0.4 gives me 150. Now I know I said this is going to match the units here, so I know it's going to be miles, but let's also think about this. Miles times inches, when I go across, gives me miles times inches. We can't multiply those together. However, then when we divide out the inches, we're left with only miles. That's another way to make sure you have the units correctly. And let's just make sure we answer this fully since this was a word problem. The distance from Nashville to Memphis is 150 miles. Okay, let's also talk now about actually creating these scale models. So let's look at this one. Example 2, find the scale. So there's a mini replica of a 1923 checker cab. The length of the model is 6.5 inches. The actual length of the car was 13 feet. First, we want to know what is the scale of the model. So I know that the model is 6.5 inches. The actual length of the car was 13 feet. So just like on the map, we're going to put 6.5 inches to 13 feet. That's similar to how the scale on the map was. However, if it's possible to reduce, we should probably reduce this. I know that 6.5 goes into 13 2 times. So I know this is 1 inch for every 2 feet. That's a simpler way to write this scale. So simplify that if you can. Now, it's asking how many times as long as the actual car is the model. This can get a little confusing if you don't read it very, very carefully. So what we're going to do is we're going to break it down piece by piece and change the words into math. So how many times as long, so that's multiplication, as the actual car, so times the actual car. So how many times the actual car is, remember is in math means equals, the model. So we'll just write the model. Now let's go ahead and fill this in. So how many times as long, that's what we're trying to find. The actual car length was 13 feet. And the model length is 6.5 inches. Now this is great. We could try solving here. However, you can't solve an equation that has two different units in it. So if we tried to divide inches by feet, that's not going to give us a good answer. we want to convert one of these so that they are going to be in the same unit. 6.5 inches is not going to convert to feet very easily, so instead I'm going to choose to convert 13 feet into inches. I know every 1 foot contains 12 inches, so I see that in order for my units to cancel and leave me with inches, I need to be multiplying by 12 inches for every 1 foot. 13 times 12 gives me 156. So I know that 13 feet is 156 inches. So I'm actually going to rewrite this. Now I can solve. So I see that I need to divide by 156 on both sides. So I have 6.5 divided by 156. And that's obviously going to give me a decimal. But what I can do is change that decimal to a fraction. It would be 1 over 24. And remember, inches divided by inches will cancel out. So I get 1/24. Now let's think about this. How many times as long as the actual car is the model? You'll have to take the actual car and shrink it. So think about the scale. If you were dilating the image, if you were taking the actual car and multiplying by a fraction, it will become smaller to make the model. So you need to be multiplying by a number less than 1 to shrink down the size. Something that's actually really nice is that if this question was asked the other way around as well, if it said how many times as long as the model is the actual car, the answer is just the reciprocal. The model, if you multiply it by 24 over 1, you will get the length of the actual car. Okay, I want you to pause and try the problem below. Here are the correct answers. Now let's try to see if we can construct our own model. So it says, suppose you want to build a model of the St. Louis Gateway Arch, which is 630 feet tall in real life, that's no more than 11 inches tall. Choose an appropriate scale and use it to determine the height of the model. So in this case, this is kind of a subjective problem because it's no more than 11 inches tall. So as long as you make your model less than 11 inches or equal to 11 inches, you might get different answers, but your model still may work. So what I'm going to do, I know that 10 is going to go into 630 really easily. So I'm going to make my model, height of the model is going to be 10 inches. That's going to fit within the constraints. Now, I also want to answer the scale. It asked me what's the scale. So I know 630 feet is going to correspond to 10 inches. Now, I know I could reduce this. I picked 10 purposefully because I knew that it would reduce really easily. I know that every 63 feet on the actual real life arch is going to correspond to 1 inch on my model. So that's my scale. Every 1 inch on the model represents 63 feet in real life. Okay, there's a practice problem for you on this one. Remember, this is just a sample answer because you might have had something a little different. So I chose a 6 inch by 7 inch drawing, but yours may be different. Okay, so what is the importance of similarity in everyday life? I want you to think about that and see if you can answer it in a couple of complete sentences. That's the end of this chapter. We've learned a lot about similarity and how it applies to scale factors and scale drawings. I hope that you've learned a lot. We'll be back in the next unit for more. See you then.